We've already seen how to name alkanes. For example, this alkane is 5 carbons, 1, 2, 3, 4, 5, and we know it's called pentane. So what do we do if we're trying to name alkenes? So this compound has a double bond present, but there's also 5 carbons, 1, 2, 3, 4, and 5. So we start with pent, indicating 5 carbons present, but since there's a double bond, we need to change our ending from ANE to ENE. So let me write in here ENE, and we'd call this molecule pentene. We want to number it to give the lowest number possible to our double bond. So we start from the left. This would be carbon 1, this would be carbon 2, 3, 4, and 5. So our double bond starts at carbon 1, and we could write 1 pentene. If you leave the 1 off, it's implied that the double bond starts at carbon 1. What if we tried to number this starting from the right? So if we said that this was carbon 1, that would make this carbon 2, carbon 3, carbon 4, and carbon 5. So you're saying the double bond would start at carbon 4, and this would be 4 pentene. That's incorrect because our goal is to give the double bond the lowest number possible. So we'd call it 1 pentene or just pentene. Let's look at this next example here. So our goal is to find the longest carbon chain that includes the double bond, and we want to give the double bond the lowest number possible. So the longest carbon chain that includes the double bond, we would have to make this carbon 1. And this would be carbon 2. This would be carbon 3, this is 4, and this is 5. So a 5 carbon alkene would be pentene. You could put the 1 in there, or you could leave it off. Next, you think about the substituents. In this case, we have only one group coming off our carbon chain. It's a 2 carbon alkyl group, and we call that ethyl. So with an ethyl group coming off carbon 2, we would call this 2-ethyl pentene for the name. But that's not the longest carbon chain. So someone might look at this molecule and say, wait a second, shouldn't this be carbon 1, and then this 2, 3, 4, 5, and 6? Because that's 6 carbons, and 6 carbons is, of course, more than 5. The problem with this is the double bond, the alkene, is not a part of our longest carbon chain. And that's one of our rules. We need to make the longest carbon chain that includes the double bond. And that's why we name this as a pentene derivative and not numbering it according to the way I did on the right here. So this is incorrect. So we find the longest carbon chain that includes your double bond and give the lowest number possible to your double bond. That's true even if you have some alkyl substituents. So let's look at this next example, and let's name this compound. So first, let's try numbering from the left to the right. This would be carbon 1, this would be carbon 2, this is carbon 3, carbon 4, carbon 5, and carbon 6. A 6 carbon alkene would be called hexene. So let me write that in here. So hexene, and our double bond starts at carbon 2. So here we can see our double bond starting at carbon 2. So I'm going to put a 2 in front of this, so 2-hexene. Next, let's think about the substituents coming off of that longest carbon chain, including the double bond. We have a methyl group coming off carbon 2, another methyl group on carbon 4, and another methyl group on carbon 5. So 3 methyl groups would be called trimethyl. So let me write that in here. So we have trimethyl, and those methyl groups are on 2, 4, and 5. So 2, 4, 5, trimethyl 2-hexene would be the name for this compound. There's another way to name this molecule. Instead of putting this 2 in front of the hexene, you can put the 2 between the hex and the ene. So let me write out that way. So we'd still have methyl groups at 2, 4, 5. So 2, 4, 5, trimethyl. Let's write hex, and then we'll put the 2 in here, hex 2-ene. So again, the 2 right here indicates the double bond starts at carbon 2. This first way of naming it, 2,4,5 trimethyl 2-hexene, this is more of the old school way of naming this alkene. 2,4,5 trimethyl hex 2-ene is more of the newer way, but currently most people would accept both ways to name this alkene. What if you tried to number this from the right to the left? If you said that this was carbon 1, and this was carbon 2, and this was carbon 3, carbon 4, carbon 5, and carbon 6. You might think this would be correct because this would give you methyl groups at 2, 3, and 5. And thinking about the first point of difference rule, right, we have 2 here and a 2 here, but we have a 3 here versus a 4, and we know that 3 is of course a lower number. So you might think that the alkyl groups would lead you to number it starting from the right. The problem with this way is this would give you an alkene that starts at carbon 4, a double bond that starts at carbon 4, and our goal is to give the lowest number possible to the double bond. And we want to give the double bond the lowest number possible, and that's over any alkyl groups, which is why we number it the way we did. And 2,4,5-trimethyl-2-hexene is the correct IUPAC name for this compound. Next, let's look at cyclic examples. So down here on the left, we already know this is cyclohexane with an ANE ending. If we put a double bond in, we have cyclohexene. So let me write that in here. This is called cyclohexene. So ENE. So either one of these carbons could be carbon 1. So this carbon or this carbon, either one of them could be. Let's just say this one is. If that's carbon 1, then this must be carbon 2, and so on around the ring. 3, 4, 5, and 6. What if you have substituents? Let's look at this example down here on the left first. So we want to give our substituent the lowest number possible. So here's our double bond, so we can make this one carbon 1 or the one below it carbon 1. To give this methyl group the lowest number possible, we make this top carbon here carbon 1. So that's carbon 1 and this is carbon 2 and so on around the ring. So this is a cyclohexene ring. So let me write this down here. So cyclohexene. And we have this methyl group coming off carbon 1. So we would write 1-methyl cyclohexene. What about this one right here? So again, we have a cyclohexene ring. So let me start by writing that in. So cyclohexene as our parent name here. And we have a choice. Here's our double bond. We could make this one carbon 1, or we could make this one carbon 1. Well, if we make the bottom one carbon 1, that gives this substituent a lower number, right? So this would be carbon 1. We have to follow the double bond around the ring. So if that's carbon 1, this is carbon 2, and that makes this carbon 3. So let's think about those substituents. At carbon 3, we have 2 methyl groups. So that's dimethyl. So let's write that in here. So dimethyl cyclohexene, and those 2 methyl groups are both on carbon 3, so 3,3-dimethyl. And then we have this ethyl group here coming off of carbon 1. So this is an ethyl group, so let's write that in. So we have 1-ethyl, so 1-ethyl, 3,3-dimethyl cyclohexene. And don't forget about the alphabet rule. So ethyl comes before methyl, right? E comes before M, which is why we put the ethyl first in the name. So 1-ethyl, 3,3-dimethyl cyclohexene.